All right, so we're talking about the fundamental counting principle today. So when we were making our tree diagrams last week, at the end of building your tree diagram, we then built a sample space and we were able to see, okay, how many total outcomes based off of the sample space we had. The fundamental counting principle is essentially a method of finding out how many outcomes you're going to have in a compound situation. It doesn't tell you what the outcomes are like a tree diagram would. A tree diagram literally maps out what the specific outcomes look like. The fundamental counting principle, all it does is it tells you exactly how many, like what your total is going to be for your probability. So the way it does is it uses multiplication of each possible activity. The total number of outcomes for one activity multiplied by the number of outcomes for another activity. It just multiplies. And that's what we're going to be doing a lot of for the remainder of our probability unit is multiplication of probabilities, because we're going to be doing a lot of compound events. And you're going to learn the difference between events that are called independent versus events that are dependent. And we'll get into that later this week. So we're using multiplication instead of a tree diagram. So again, your tree diagram will map out what each individual outcome will look like. The fundamental counting principle is just a shortcut that's going to give out the total number of outcomes for your sample space. So for example, when we're flipping 2 coins, the total number of outcomes is going to be 4, because you have 2 outcomes for one coin and 2 outcomes for another, and 2 times 2 is 4. It doesn't tell us what kind the outcomes are. It doesn't tell you that it's heads, 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 tails, tails, heads, and tails, tails. That's a tree diagram. But at least you can figure out how many total outcomes you should have or what your probability should be based off of. So we're going to look at a couple of just real quick, simple activities. And we're going to calculate what the total number of outcomes would be. So if I take a coin and a die, am I being told a number up here?
No.
No. But do I know how many outcomes a coin has? How many outcomes? Or outcomes, not outcoins. Outcomes is 2. And what about for the die? How many outcomes? 6. So again, fundamental counting principle says I'm going to do what? I'm going to use, come on guys, wake up. Multiplication. I'm going to use multiplication. So if I am flipping a coin and rolling a die, then I have a total of 12 outcomes in my sample space, which makes sense. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. Tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. That's 12 total outcomes. Doesn't tell me what the outcomes are, but at least I know what the probability is based out of. Sometimes they will give you numbers. Like I have 3 entrees. I have 4 sides. And I have 2 desserts. And if a question asks how many different combinations can you create, that means how many different total outcomes can you have to combine different choices of entrees, sides, and desserts together. So how many combos? Very good. 24, because you have 3 entrees. You have 4 sides. You've got 2 desserts. And again, the fundamental counting principle just says you multiply those together. So that's 24 combos that you could create, or outcomes. I want to know how many different ways can I pair a boy and a girl together. Again, is it giving me any numbers up here? No. But can I count how many boys and girls I have up here?
Yes.
Yeah. How many girls do I have? 3, right? My girls I've got are 3. How many boys do I have? 2. And the different ways I can pair a boy and a girl together is 6. I can pair them 6 different ways. Always. That's what the definition is of fundamental counting principle. You multiply the different possible outcomes. I want to choose a number 1 through 9 and a letter from the alphabet. How many numbers are between 1 and 9? 9 numbers. How many letters are in the alphabet? 26. So now I multiply 9 times 26. 234. Very good. So again, this is just a process of being able to calculate the total number of outcomes a given probability will have. You can also use this process to find the probability of specific events happening without having to have the sample space sometimes. So let me show you what I mean. Let's go back to that idea of a coin and a die. So let's say that I want the probability of flipping the coin and landing on heads and rolling the die and getting a number that is greater than or equal to 3. I want to flip the coin and land on heads, and I want to roll the die and get a number that is greater than or equal to 3. All I'm going to do is split it up just like I did with the fundamental counting principle. I'm going to split the probabilities apart as if they were separate probabilities. So probability of flipping the coin and landing on heads, and then the probability of rolling the die and landing on a number that's greater than or equal to 3. Now you want to use your fractions for these. So what fraction is the probability for landing on heads? 1 over 2. What's the fraction for rolling a number that is greater than or equal to 3? Not 3 over 6, not 1/2. Greater than or equal to 3. Think of the numbers that are greater than or equal to 3. Let's start. Is 1 greater than or equal to 3? No. What about 2? What about 3? There's one of them. 4? Yep. 5? Yep. 6? Yep. How many numbers? 4 numbers. There's 4 numbers. So when we're talking about greater than or equal to 3, we're talking about the values 3, 4, 5, and 6. That's 4 numbers out of 6 on the die. Then all you have to do is multiply them. You don't even have to simplify that right now, because if you multiply 1/2 times 4, 6 in your calculator, it'll simplify it for you. Go ahead and do that. What do you get? 1/3. Very good. So the probability of landing on heads and a number greater than or equal to 3 is 1/3. You just take each individual probability and multiply them. Yep. Let's say that we are rolling a die 2 times in a row. So if I roll the die and land on a number, can I not land on that number again?
Yes.
No. You can still land on that number. Think about it. If I roll the die and I land on this 2, is it impossible for me to land on 2 again?
No.
No. It's very possible. It might not happen. You know, it's an unlikely event, but it could. Well, I landed on 4. But sometimes you just land on the same number twice in a row, and that's okay. So you need to remember, when we get to it, that would be called an independent event. But here's what I'm trying to do. I'm going to roll the die, and I want to land on 2, and then land on an even. So let's split those probabilities apart. The probability that we're going to land on the 2. What's the probability of rolling the die and landing on 2? 1/6, right? The 2 only happens 1 time out of 6. Okay? The probability that I'm going to land on an even number, 3 out of 6. Good, because what are my even numbers? 2, 4, and 6. Those are my even numbers, 2, 4, and 6. There's 3 even numbers out of 6. And then you just multiply. 1/6 times 3/6 is 1/12. Any questions about this? It's pretty simple. You're just multiplying. Okay? Your activity for today, you are going onto the quizzes link. Make sure you log on to Google your G Suite first, then go on to the quizzes activity. Let me get it loaded right now.